All right, this is Jonathan Sarine, and
Gabriel Partridge.
Yep, we're Group 17, and we're doing Lab 6. So we'll just jump right into it. Here we have the original file that we're looking at, and we want to talk about how it kind of shows how it's going to be divided up into different parts.
We threw in the red line there just to show that the address and the write enables that are below it are mainly just used together in the decoder, and the clock input and the inputs for the bits work with the output to be in the register files.
Right, and here you can kind of see how it was. This is the end product, the 4-bit 8-word register, and there you still see the 4 inputs, the 3 address inputs, the write enable, and how they each go to a different segment. Like the 3 address inputs go to the decoder, and the decoder, how it works, you got the 3 address lines, and we can see this math that goes on here. 2 to the power 3 is 8. So we know that because there's 3 address lines, there's going to be 8 registers, and the decoder is going to feed those registers with the address, basically. And this 4-bit 8-word register is a single ported register, which means that the write enable goes to both the decoder and the addresses, go to the decoder and also the mux on the other side here on the right end.
Here we've got the transition table showing that the next Q value is going to be whatever the D is with the write enable on, or whatever Q currently is with the write enable off.
Here we have more about the 3 to 8 decoder, which determines which address is written to, and this happens on the rising edge of the clock because how the D, right? And we thought we saw something interesting with this, that the NOT gates allow for the even addresses. You can see that the NOT gates going here are going to a lot of the even addresses here. And we just thought that was something interesting in the logic. And here we have a 1-bit register.
And we just had this reused multiple times to make the 4-bit registers.
Right, this is just the smaller section of the modularization that took place when building this 4-bit 8-word register. And here's the 4-bit register, which is built from the 1-bit registers you just saw.
And this is just the overall of the entire register, the 4-bit 8-word. And we found while working on it that the splitters helped everything just look so much cleaner, so that we didn't have wire lines going everywhere. And this is just showing the specific the 4 inputs and the clock input. Those 5 wires together, we've got them on the input for all of the registers, and then we've got the output for the registers still matched to the same 0, 1, 2, and 3 coming out of the registers to the mux.
This clearly shows the single portedness of the register file, how there's the address lines going to both the decoder as well as the multiplexer down here just before the outputs. And here we have the whole, or I suppose it's the opposite of subcircuit, how the whole thing would look as just one part, the way we did the modularization. If you wanted to put a 4-bit 8-word register into another system, this is how that piece would look. And it actually somewhat matches the initial design of this piece, which is shown here on the right. And well, that's it for our presentation. Thank you so much.